All right, so we want to solve these without using a calculator. We're just going to use these inverse properties up here that we get out exactly what we put in as long as our x is in the range of the outside function. So that means we need to know the range of our functions on the outside to be able to work these problems. All right, so what function is on the outside of our first problem? It's cosine. All right, so let's think about the range of cosine. It's from -1 to +1. So the thing we want to ask ourselves is -0.4 in the closed interval from -1 to 1? Is -0.4 in this interval? The answer is yes. So that means our answer is -0.4. All right, so it's exactly what we put in the problem. It's exactly what we expected to happen. Okay, let's look at the next one. Oh, this is a mistake. Let me fix this problem. This is sine inverse of sine of pi over 12. All right, so notice what's on the outside. Sine inverse. So we have to think about the domain of sine inverse. Okay, so we have to ask ourselves, is the number on the inside pi over 12 in the domain of sine inverse? Is it in this interval? All right, so if you want to put in your calculator to check, you can. I see that this is, pi over 12 is really small, so it's going to be in this interval. So the answer is yes. The answer is what's expected. The answer is just pi over 12. Composing two inverse functions, we get out exactly what we put in. All right, let's look at the next one. All right, this time the outside is the same, sine inverse, so we're asking ourselves the question, is 3 pi, oh, so many typos, this should be 2. This is sine inverse of sine of 3 pi over 2. Sorry about that. So the question is 3 pi over 2 in the range of sine inverse? So is it in -pi over 2 to pi over 2? It is not, right? It's way too big. It's not in that interval. Let's take a look at it. Here's 3 pi over 2. So pi over 2 is here, -pi over 2 is here, but in the opposite direction. It's coterminal to what we want. So we're going to use that to get an answer. Okay, so now our answer is no, so that means our answer is not going to be 3 pi over 2 because that is not in the range of sine inverse. So what do? We actually work it like a normal composition of functions. All right, so we take sine inverse of sine 3 pi over 2. All right, so remember we have to figure out the inside first when we're doing composition of functions. So what is sine of 3 pi over 2? Well, here it is on our unit circle. Sine of 3 pi over 2 is -1. So that means we can replace sine of 3 pi over 2 with -1. Okay. All right, and so how do we figure out sine inverse of -1? Well, remember, this gives us an angle theta. So that means we're looking for an angle theta such that sine theta equals -1. Okay, we've already found it. Sine theta equals -1. That happens at 3 pi over 2, but that's not the right number. We want it to be between -pi over 2 to pi over 2. So what are we going to do? We're going to get a coterminal angle. Let's subtract 2 pi. And we get something that's in our interval. -pi over 2 is the answer. So it's in the same location, but much smaller. Okay, let's look at the next one, tangent of tangent inverse. So let's think about the range of tangent is 11 in this interval. Of course it is. All numbers are there. Yes, so the answer is 11. Okay. All right, let's look at the next one. Tangent inverse of tangent of negative pi over 4. Here's the outside function. What is the range of tangent inverse? It's negative pi over 2 to pi over 2, open brackets, or parentheses, I mean. So is negative pi over 4 in the interval between negative pi over 2 and positive pi over 2? Of course it is. So that means the answer is negative pi over 4. Okay. All right. Now let's look at the next one. Sine inverse of sine of pi. So here's our outside function. We know the range is from negative pi over 2 to positive pi over 2. So is pi in negative pi over 2 to pi over 2? The answer is no, it's not. So then what do? That means we go back old school. We have to actually do the composition of these two functions. Sine inverse of sine of pi. All right, so again, with inverse functions, we have to do the inside first. So what is sine of pi? It's 0. Okay, sine of pi is 0. So we're trying to find sine inverse of 0, which, remember, our answer should be an angle. So we're trying to find the angle such that sine of theta equals 0, and we want our answer to be in this interval. So can we find a place where sine is 0 in the interval from negative pi over 2 to positive pi over 2? We should. It happens right here at 0. So the answer is 0. Okay. Finally, let's do sine of sine inverse of pi. Sine is on the outside, so let's remember what's the range of sine. Negative 1 to positive 1. So question, is pi in the range? Is it between negative 1 and positive 1? Question, what does pi equal? 3.14? That's way too big. The answer is no. Okay. So our answer is not going to be pi. So let's look at this. Sine of sine inverse of pi. So in order to figure this out, the inside, we're trying to find the angle. Remember, this is an angle, sine of an angle. We're trying to find the angle such that sine theta equals pi. Well, do we ever find anywhere on our unit circle where sine is pi? Of course not. Sine is only between negative 1 and positive 1. This will never happen. This is actually undefined. It's never going to be the case where sine theta equals pi. And it's because the range of sine is from negative 1 to positive 1. So here we have our problem is undefined.